Welcome to my YouTube channel. Our today topic is, what is molded case circuit breaker? MCCB explain in details. Molded case circuit breaker. A molded case circuit breaker (MCCB) is a type of electrical protection device designed to protect electrical circuits and equipment from overcurrents, short circuits, and other electrical faults. It is commonly used in various industrial, commercial, and residential applications. Here are the key components and features of a molded case circuit breaker. 1. Frame. The frame is the outer enclosure of the MCCB and provides mechanical strength and protection. It is usually made of molded insulating material, such as a high-strength, thermosetting plastic. 2. Operating mechanism. The operating mechanism is responsible for manually or automatically opening and closing the circuit breaker. It typically consists of a handle or lever that can be operated by hand or through a motorized mechanism. 3. Trip unit. The trip unit is the core element of the MCCB and is responsible for sensing overcurrents and initiating the tripping action. It monitors the current flowing through the circuit breaker and can be designed to provide different types of protection, such as thermal, magnetic, or a combination of both. Thermal protection. The trip unit measures the amount of current passing through the breaker and activates the trip mechanism if the current exceeds a specific threshold for a predetermined period. This protects against sustained overloads that can overheat the circuit and cause damage. Magnetic protection. The trip unit incorporates a magnetic coil that generates a magnetic field. If a short circuit or high current fault occurs, the resulting magnetic field will cause the trip unit to instantaneously trip the circuit breaker, providing fast protection against short circuits. Adjustable settings. The trip unit of an MCCB often includes adjustable settings to customize the protection characteristics according to the specific requirements of the application. These settings may include adjustable trip current levels, time delays, and other parameters. 4. Contacts. The contacts are the conducting elements of the MCCB that allow or interrupt the flow of current. When the circuit breaker is closed, the contacts are in a conducting state, allowing current to flow through the circuit. When the breaker trips, the contacts open quickly to interrupt the current flow and isolate the faulty circuit. Main contacts. The main contacts are responsible for carrying the normal rated current of the MCCB under normal operating conditions. Arcing contacts. The arcing contacts are specifically designed to handle the high energy arcs that occur when the main contacts open. They are made of materials that can withstand the intense heat generated by the arc and minimize its damaging effects. 5. Arc chute. The arc chute is an important component located near the contacts. When the contacts open, an arc is formed between them due to the current interruption. The arc chute helps extinguish the arc by creating a controlled path for the arc to travel and cool down. It consists of a series of arc splitters and plates that rapidly separate and quench the arc. 6. Trip indicator. Many MCCB are equipped with trip indicators that provide visual or mechanical indication when the circuit breaker has tripped. This helps in identifying the cause of the trip and facilitates troubleshooting. 7. Accessories and features. MCCB can be equipped with various accessories and features to enhance their functionality and protection capabilities. These may include auxiliary contacts for remote monitoring, shunt trips for remote tripping, undervoltage releases, ground fault protection, and more. Advantages of molded case circuit breakers. MCCB. 1. High breaking capacity. MCCB are designed to handle high fault currents and have a high breaking capacity. This means they can safely interrupt and isolate electrical circuits in the event of a fault or short circuit, preventing damage to equipment and minimizing downtime. 2. Compact size. MCCB are typically more compact compared to other types of circuit breakers such as air circuit breakers or oil circuit breakers. Their compact size allows for efficient use of space in electrical panels and switchboards. 3. Easy installation. MCCB are relatively easy to install and replace. They are designed for plug-in or bolt-on installation, which simplifies the process of adding or replacing circuit breakers in electrical systems. 4. Adjustable protection settings. MCCB often feature adjustable trip settings, allowing users to customize the protection characteristics according to the specific requirements of the application. This flexibility enables optimal protection and coordination with other protective devices in the electrical system. 5. Wide range of current ratings. MCCB are available in a wide range of current ratings, making them suitable for various applications, from residential to industrial. This versatility allows for the selection of the appropriate MCCB based on the specific current requirements of the electrical circuit. 6. Reliable operation. MCCB are designed for reliable and consistent operation. They undergo rigorous testing and comply with industry standards to ensure their performance and reliability in protecting electrical systems. Disadvantages of molded case circuit breakers. MCCB. 1. Limited short time withstand rating. MCCB may have a limited short time withstand rating compared to other types of circuit breakers, such as air circuit breakers. This means they may have a shorter duration for withstanding high fault currents before tripping. 2. Restricted maintenance. MCCB are typically designed as sealed units, which means they do not require regular maintenance or inspection. While this is advantageous in terms of convenience, it can limit the ability to perform detailed maintenance or repair on individual components within the MCCB. 3. Higher cost. Compared to some other types of circuit breakers, MCCB can be relatively more expensive. The cost of MCCB can vary depending on the brand, features, and current rating. However, it's worth noting that the cost is often justified by the performance, reliability, and safety features offered by MCCB. 4. Limited fault detection capabilities. While MCCB offer protection against overcurrents and short circuits, they may have limited fault detection capabilities compared to more advanced protection devices, such as digital protective relays. MCCB primarily rely on thermal and magnetic trip units for protection, which may not provide detailed fault information or advanced fault analysis. 5. Limited coordination with other protective devices. Achieving proper coordination and selectivity between MCCB and other protective devices in a complex electrical system can sometimes be challenging. Coordinating the tripping characteristics of MCCB with upstream and downstream protective devices is important to ensure that the circuit breaker closest to the fault operates to isolate the fault while minimizing disruptions to unaffected areas.